Assalamu alaikum. So today we will be tackling this problem, which is design a circuit that controls the rear lights of a car, left and right rear lights. So we will be designing this circuit on Proteus, and we will be doing this through a mux. So first of all, let's look at the input that we have. So first is the left turn signal, which causes the blinking of the left side light, which is left rear light. Then right turn signal, which causes the blinking of the right rear light. Then emergency flasher, this will cause the blinking of both the rear lights. Then brake, which is when brake is applied, the both lights will remain on till the period the brake is being applied. And then we have the blinking, which is a signal with a frequency of 1 hertz. Now and the outputs that we have two outputs which we know, left and right rear lights. So for that, left and right. Now some more information which is given about the significance is that the brake beer overrides the emergency signal, and the right turn and the left turn overrides the brake signals, which means that the left turn and right turn are the most significant inputs and emergency signal is the least significant input. Okay, so now here we have the truth table. We can see that one for the left light and one for the right light, and here are all the 4 of our inputs, and the output is here in the blue. So we can see that when the first row, when all the inputs are off, so the light will be off obviously. When the blinking is on, the light will still be off, because we know that neither we are giving it a left turn signal nor the brakes nor the emergency signal, because the blinker will only work if it is given with these two signals alone. The blinker signal will not give us an output, because no other function, because blinking is not itself a function, it is combined with the left turn and emergency signals. On the other hand, brake signal is independent. So whenever the brakes will be applied, here you can see that only the brakes are applied, the left and right lights will be both turned on, whereas the emergency, which here we can see, needs the blinker with itself, is on. And here we can see left turn signal alone, we can see the output is off, but when it combines with the blinker, it is on. So this is how our system is working. So we will take any one of the columns, input column, and compare it with the output column and create its we can say the inputs for the mux. So we will divide them into 2-bit combination. So here you can see at 0 1 combination of blinker. Let's take the blinker as that constant input column and use it to compare the output with the output column. We can take any one, it's our choice, but I am taking here the blinker one. So at 0 1 the output is 0 0, which means the output is 0. So let's go to the Proteus and do it simultaneously, as you understand the table and the inputs of the mux. So let's create new project, which is car lights. Created a new project. Let's pick up some basic components, which are first the inputs, logic state. Here I have taken the logic state for the inputs, then logic probe for the output. Then we need our mux, which is 74151. So here we have a mux. Let's first of all place the inputs here: left turn, right turn, emergency, brakes. And for blinker, we need an input signal which has a frequency also. So here use a DC clock. Let's give them name. So this is left turn, this is right turn, this is brake, and this is emergency, and this is our blinker. we saw that the blinkers frequency already set at 1 Hz, so we do not need to change them. Now let's place our mux here, this one for the left and this one for the right. So let's rename this left and this one right. Logic probes at the outputs of each of the mux, and let's connect them with the normal output or the inverted one. We should, here we can see that the output is normal on Y and then the Y bar, which will give us the inverted output. So we need the normal output, so we'll connect it with the Y. Now for the enabler, we can see to activate the mux we need to connect the enabler, and here is enablers here with a not sign, so which means that we need to provide 0 here to convert it to the high output, to make it a high input, sorry. So I'll place another logic state here which will remain constant at 0. So let's rename this cons 0, and let's connect the enabler in with this. Let's connect the other right one also here. Now both our mux are connected and enabled. Now let's set the significance. So here the pins A, B, C are for the significance. A is for the least significant and C is for the most significant. So as we know, left turn is the most, left and right turn are the most significant. So connect here with the C and the right one here with the here. B, the second most significant is the brakes, so here connecting them to brakes, and the least significant we have emergency, so here is the emergency. Okay. Now let's look at the map here. So for the first one, for the first input pin of the mux, we'll compare the BL column with the output column. I am taking the BL column to be the constant and means of comparison. So we'll divide it into 2 bits, combination of 2 bits. So here we can see that the first combination is 0 1. So for 0 1 at the output we have 0 0, so which means that the output will be 0 for BL. So left will be. So here let's connect the first 2 pin to 0. So here we have a constant 0. We have a constant 0 input. So let's connect it here. Okay, now let's look at the second one. For 0 1 we have 0 1, which we can say the left is equals to BL. Let's connect this to BL. Where is BL? Connecting it to BL, and then for the third 0 1 we have 1 1, which is equals to 1. So we need again a constant 1 here. So I will place another logic state here and make it constant 1. It will always remain at constant at 1 high state. So let's change its state. So let's give it constant 1 and connect it with the third input, that is 1. Okay. Now again let's move the fourth is also 1, so I can just simply connect this one here, and for the fifth one is equals to BL. This one is also equals to BL, this one is also equals to BL, and this so all the other 1 2 3 4 combinations are inputs are equals to BL. So let's connect 1 to BL, all the others then to 1 2 3 and 2 3 4. Okay, so left is completed. Now let's do the similar for the right one, because both the truth tables are same. So first one to 0, so here is 0. Second one to PL here. Third one to 1. Fourth one to 1 again, and then fifth one to PL. Here is PL, again PL, 4 times. So yeah, here it is. So I think both of our circuits are done. Let's run this, change the constant 1 to 1, and let's now change the inputs and see. So for 0 0 0 0 we can see we have both turns, both lights off. For 0001, which means that only blinker is on, all the others off. So again we can see blinker is already on and all the others are off. So now for the emergency and blinker on, so that's, you can see the emergency is on and the blinker is on. So we have blinking emergency, both the lights are flashing. Now let's go for the left turn only. So left turn, we can see the left turn and the blinking is on, so our left signal is blinking. Turning the right one on, so we can see now both are blinking. Only the right one and the blinker on, right one is blinking. Now to check the significance, before that let's check our brakes. You can see the brake is on, both the signals, both the left and right lights, rear lights are on. Now let's check for the left and right significance. So I can see turning the left one on and the emergency, and the blinking is on, and the brakes are on. So we can see that left turn is giving high bigger importance, so it is being blinking, and not the brakes, and it is not constant one. Similarly for the right, we can see now both the right and left turn signals are blinking, lights are blinking, and we can see that BR is not significance than the left and right turn. So we have completed our circuit, and we can see it is working perfectly fine. Thank you.